Today we'll be working on sheet 3.6 solving quadratic equations by factoring. What I like about this worksheet, it's basically a review of everything in chapter 3 so far. So it's going to prepare you for your quiz on Tuesday and your test on Friday. So let's start. I'm going to do a couple of questions and take notes. And the other questions please do on your own so we can check together on Monday. Now let's look at number 1. When they ask you for a solution, before we start solving, let's ask ourselves, what does a solution mean? In other words, when they ask for a solution, what do they really want? They either want the root, the zero, or in other words, they want the x-intercepts. All of those mean the same things. Solution, root, zero, and x-intercepts. So when they ask you to solve this, a quadratic equation, it means they want the solution, they want the x-intercepts, they want the root. So this is something written in standard form. If you change it to a root form, it means you factorize it, you factor it, then you can find the x-intercepts. So in order to do that, you have to move everything to one side of the equation. Remember to always keep the x squared positive, it's easier to solve. So subtract x, subtract 30, and move everything to the other side. Nothing will be left on the other side, so it will equal to 0. So set the equation equal to 0. It means move everything to one side of the equation. Now, you would solve this quadratic equation like you would any other, like we learned in 3.5. You factor it. You either take a common factor, you either factor the negative out, you use difference of two squares if it's a binomial, or you do big X if it's a trinomial. This is a trinomial. A is 1, so you need two numbers when you multiply to get negative 30. And whenever you add, you want to get negative 1. So the two numbers are, think of negative 30, think of all the factors, like negative 3 and 10, but they don't add to negative 1. Negative 6 and 5. So I think negative 6 and 5 are the right answers. As you can see, if you multiply them, you do get negative 30. If you add them, you will get negative 1. So negative 6 and 5 are the two numbers you're looking for. So to factor this, you put x minus 6 into x plus 5. Remember, you usually divide by a, but since a is 1, it's not going to change your answer. So this is all equal to 0. Now, as you can see, I factored completely, so I did the first and second step. Now you need to find the x-intercept. So as you can see, this moved 6 units to the right, and this moved 5 units left. Or basically, if you want to solve it, you just set each one of them equal to 0. So this is 6. So x is equal to 6, and you set the other one equal to 0. Because both of them, as you can see, they're both equal to 0. So minus 5, x is equal to negative 5. So these are the two roots, the two x-intercepts. So the two roots are negative 5 and 6. These are the two x-intercepts. It means if you plug them in the equation, if you plug them in here, if you plug those two in here, you're going to get a 0. Or if you plug it in here, you're going to get a 0. Or here, you're going to get a 0. So this is what a solution means. It means this is the x-intercept where it cuts or crosses the x-axis. And on the x-axis, the y is equal always to 0. Now again, you do the same thing over here. You set the equation equals 0 by taking everything to one side. Then you factor it. Then you set each factor equal to 0 like I did here. Now, as you can see, this is a binomial number 3. So there's something in common. Go ahead and take x in common and solve it. Now also here you need to move everything to one side. I prefer if you move those two to the other side, so you would keep this positive. Or you can move 2x squared to the other side and then factor out the negative. So this is how you would do solving quadratic equations by factoring. Now if you move on to number 5, Number 5 is basically 3, 1. It's a review of 3, 1 and 3, 2. It has nothing to do with solving an equation, or basically maybe it has to do like vaguely with it, but let's look at the vertex for something like this. If you want to find the vertex, remember x equals negative over b over 2a when it's in a standard form. A is 1, b is 4, c is 3. So it's going to be negative 4 over 2 times 1. So basically it's negative 2. This is going to be the vertex. It's negative 2. To get the y, you plug it in. So by plugging negative 2 in, let's try that. So y is equal to negative 2 squared plus 4 into negative 2 plus 3. You will get at the end negative 1. So negative 2, negative 1, that's your vertex. Negative 2, negative 1, this is going to be your vertex over here. So the minimum, it's a minimum since a is positive. As you can see, a over here is plus 1, so it's positive. It means it's going to be something like this. So it's going to be a minimum, and the minimum is the vertex, negative 2, negative 1. The domain is always going to be negative infinity to infinity, and the range is going to be from the minimum all the way up to infinity, so it's going to be negative 1 to plus infinity. The axis of symmetry is always going to be equal to the x of the vertex. Now the roots, wherever it's going to cross the x-axis, remember when you want to graph it, you would take 2 points to the right and 2 points to the left, and then to find those 2 points you would just plug it in the equation. You would plug it in the equation to find the y. So if you plug in 0 over here, it's going to be 3, because this is the y-intercept, so this is going to be 3. If you plug in negative 1, you're going to get 0, so this is going to be 0. So if you just plot the points, so this would be a graph. It's going to look something like this. This is one way of graphing it, but I'd like to show you a trick. So I'm going to erase it. To be able to graph using the trick, you always start with the vertex. So you need to find the vertex anyway. And the vertex in this case is negative 2, negative 1. Now by looking at the quadratic equation, a is 1. So since a is 1, it means that you can, basically it's just like the parent function, which is basically, it's the parent function, which is, for example, starts at 0, 0, then 1, 1, 2, 4, and so on. Since the a is positive, so basically you start with the vertex, and this is 1, so you move up 1 and to the right 1. Or you can move up 4, okay? So let's do that. Up 1 and to the right 1, so this is going to be my first point. And then you move up 4, so 1, 2, 3, 4, and then 2 to the right. Okay, you always start with a vertex and you count, and the third is going to be 3, 9. This is if you continue the parent function. The reason why we're using the parent function is that a is 1. So let's continue. So 9. So you can count 1, 2, 3, 4, 5, 5, 6, 7, 8, 9, and then 3 to the right. So it's going to be a point over here. 3, 4, 5, 6, 7, 8, 9, and then 3, so a point over here. And as you can see, basically it's always going to be symmetrical to each other. So you connect those points. And remember, we can do that like you use the table of the parent function, because it's the a is 1. So let's move on to the next. Now by moving on to the next page, you can see that the vertex is 2, 0. So I'm going to use the same just to help you graph it, but you're supposed to do the rest on your own. So 2, 0 is your vertex. Now what you can do to create the points, you can start with the parent table. So I'm going to draw the parent table somewhere. Keep in mind that the a is 3. So it's not going to be exactly like the parent table, but you can use the parent table to graph. So the parent table is going to be 0, 0, 1, 1, 2, 4, 3, 9, and so on. Now what you can do is, you know that the vertex is going to be, usually before it's 0, 0. Now it's 2, 0. And since a, let me write down the equation, the a is y equals 3 into x minus 2 squared. So the a is 3. So you can look at this. It's 1, it means it's going up 1. But since a is 3, you multiply 1 times 3, so it's 3. So it means you go up 3, 1, 2, 3, and then 1 to the right. So up 3 and 1 to the right. And the reason we're doing that is because it's being stretched by a factor of 3, vertically stretched by a factor of 3. So you do not change the x, just the y you multiplied by 3. Now here, of course, you're going to have something that's symmetrical. So it's going to be somewhere over here. It's not very precise. It has to be on that pretty point. Let me erase it and make it clearer. So it's going to be somewhere over here. And it's going to be symmetrical, so somewhere over here. So 4 times 3 is going to be 12. So it means you have to go from the vertex. Remember, you always count from the vertex. You have to go up 12 and then 2 to the right. So up 12 is going to go, it's going to be somewhere over here and up. So it's going to be here, another point over here. So basically this is it. Now, so what you're doing is basically you're counting from the vertex up and then 1 to the right always. So if you try to write down the points and check if they are right, they will always be right. I hope you understand this method. If not, please ask me again in class. I'll be more than happy to give you more examples. So let's check if this is right. So if you look at this point, it's basically 3, 3. So let's plug in x equals 3 in here to see what's going to happen. So 3 minus 2 is 1, 1 squared is 1, 3 times 1 is 3, so yeah, it's 3, 3. Now if you plug in 0 for x, I'm sorry, as I was graphing, I think let me draw the points again. As you can see, symmetrical, so since this is the vertex, this point has to be somewhere over here. And this is going to be here. So this is how the graph really looks like. So it has to be symmetrical. Instead of moving just 1 step to the left, I move 2 steps. Now if you plug in 0 in your graph, in your equation, you're going to get 12. And as you can see here, when I multiplied 4 by 12, I did get 4 by 3, I did get 12. So this is how you got the point over here. Now let me just erase the graph and draw a better one. Okay, so this point over here, it has to be removed. Okay, so you have to go up 3 and 1 to the right. So it has to be somewhere over here. And the symmetrical is going to be somewhere over here. And then you have to go up 12 and 2 to the right. So it's going to be somewhere over here. And the other ones should be, if you extend the y-axis, it has to be there. So 0, 12 is going to be your point. So this would be a possible graph. So as you can see, it does work. You can just use the parent function, and you can multiply the y of the parent function by the a, which is 3, to get to know how many steps to count starting from the vertex. Now let's move on to the other question. Please continue this question on your own, number 6 on your own. I'm going to do number 7. Now, this is a review of lesson 3. So, first of all, you have to graph this one to be able to graph it and decide how to shade above or below. So if you find the vertex, so let's graph this one. What you can do is you can factor it, or you can just find the vertex and count from the vertex. So I'm going to find the vertex v, the x and y of the vertex. First of all, the x is going to be negative b over 2a. So x equals negative b over 2a. So it's going to be 1 over 2, it's half, 0.5. Now to find y, you have to square the 0.5. Then minus 0.5 minus 6. So I plugged in the x in the main equation. 0.5 squared is 0.25 minus 0.5 minus 6. So basically it's going to be negative 6.25. So the vertex is 0.5 and negative 6.25. So if you just 1, 2, 3, 2, 3. Remember, when I give you something like that, you just have to sketch it. You don't have to be very accurate. So 0.5 and negative 6.5 is going to be somewhere over here. And then in order to find the roots, because the roots will help you, this is basically what you need, the roots. We can factor it, so we learned how to factor. We don't have to create a table. So think of two numbers. When you multiply, you will get negative 6, and when you add, you will get a negative 1. So negative 3 and 2 are the points. So the factors are x minus 3 and x plus 2. So remember, when you want the roots, you set this equal to 0. So x is equal to 3. And you set this one equal to 0. And you get that x is equal to negative 2. Those are the solution, the roots, the x-intercepts, whatever you want to call them. So the 2 points are 3 and negative 2. So this is going to be one of the roots, and this is going to be the other. So you graph it. Now you want your f of x to be greater, so you color inside. And remember, it has to be a shaded one, because it's just f of x is greater, so shaded quadratic equation. So this is how you would graph a quadratic inequality. Now if they tell you that x squared minus x minus 6 is smaller than 0, what you can do, if you have graphed it, you can look at the graph. So let's look at the graph. If you want it to be less than 0, it means you want the part of the graph that is less than 0, so below the x-axis. So this is it. So as you can see, this part of the graph is between the 2 points, negative 2 and 3. So on the number line, you would put negative 2 and 3. Since it's just smaller, so open circles, and you take this. So basically, it's the interval between negative 2 and 3. It's any point between them. What you can do is you can just take a point that's 0 and plug it in. And you check if it's true statement or not. So negative 6 is smaller than 0. It is a true statement. So anything in between those 2 points, negative 2 and 3, that would be your interval. This would be your solution. Now continue the other one. Now there's another way. Let's say I gave you this to work. I gave you this to work on it, and you don't have a graph to start with. So instead of graphing it, what you can do, so another way to solve it is going to be x squared minus x minus 6 is 2, smaller than 0. So since a is positive, it's plus 1, you know that it's going to look something like this, opening upward, having a minimum. So what you can do is you can factor it. Think of two numbers you would multiply to get negative 6 and add to negative 1. So you would know that the two numbers are negative 3 and 2. So the factors are going to be, or the x-intercepts are going to be x and negative 3 and negative 2. So you know if this is the x-axis, somewhere over here, the 2 points are going to be negative 2 and 3. So what you can do is you can sketch it. You don't have to be very precise, because you're really interested only in the x-intercepts and knowing how it would open. Would it have a minimum opening upward, or would it have a maximum opening downward? This is what you're interested in. Now, since they want this y to be less than 0, so you are interested in the part of the graph that's below the x-axis. So this is how you know that you want from negative 2 up till 3. So the interval would be negative 2 to 3 would open, negative 2 to 3 with parentheses, since negative 2 and 3 are not included. So please, I hope this helped. I will answer your questions on Monday. Please finish, take notes, finish the rest of this worksheet and the front page as well, and be prepared to ask me questions on Monday. Remember, this is a very important worksheet because it reviews everything, all of chapter 3 so far. So study well, and I'll see you on Monday.